السلام عليكم ورحمة الله وبركاته. عاملين يا رب تكونوا بخير دايما وفي أحسن حال. أهلا بكم في كاردياك فيوز. Welcome in cardiac views. Inshallah, this video will resume our chain about the ECG, which is started by the action potential of the SA node. Now we'll discuss about the action potential of the cardiac myocyte itself. As we mentioned, the action potential of the SA node is different from the action potential of the cardiac myocyte itself, the heart muscle itself. Okay, so action potential of the cardiac myocyte is the same. There is external stimuli, initiate the cell to depolarized and repolarized. What's depolarization? Repolarization, it's electricity. It happens in every small cell in our body. Okay, so the action potential of the cardiac myocyte receive external stimuli, start to depolarize. Okay, actually it's the same. It's four phases, but the slope is different. The diagram is different. Okay. So external stimuli happen, depolarization initiated. How it's initiated? Phase 0, it's guided by sodium influx from extracellular to intracellular, the same like SA node, but it starts, so the action potential, any action potential starts by sodium ions. Okay, as you remember in the SA node action potential, it starts by sodium influx, slow sodium influx intracellular from extracellular to intracellular until reach to -60 in order to calcium influx in order to all of the slope and action potential of the SA node to happen. Okay, here is the same, but it's guided, fully guided. Phase 0 action potential, it's guided by sodium influx as you see here in this slope. So the sodium rapid influx from extracellular to intracellular. Why? Because we mentioned last video the concentration of the sodium, it's very high extracellular comparison by intracellular. So once the sodium channel open, rapid influx of the sodium from extracellular to intracellular in order to help the cell to depolarize, to make this upstroke. It's the positive slope that you see in this diagram. Okay, so maximum excitation happen, rapid influx of the sodium from extracellular to intracellular happen. So the cell now depolarized, it has to repolarize again. Okay, it's contracted, it has to relax it again. It will not long lasting all the time contracting. It need to relax, it need to repolarize again. So the cell cannot terminate the sodium because, as I mentioned, sodium extracellular is very high comparison by intracellular. Okay, but it can terminate little bit potassium. So some of the potassium channel open. So some of the potassium outflux from intracellular to intracellular. That makes this slow, small slope, negative slope that you see here after the upstroke. There is a small negative slope. Okay, why this negative slope? Why this negative slope doesn't complete with us for the negative slope? Because at the same times of the potassium channel that's open, there is calcium channel also open. So phase 0 guided by sodium influx. Okay, phase 1, this negative slope that you see here in this diagram. Okay, so at the same time of potassium open, there is calcium channel also open, and calcium start to move from extracellular to intracellular. So the cell itself will try to get rid of positive charge. At the same time, some positive charge, which is calcium, which is bivalent positive charge. يعني it said to the cell, you get rid of all one positive ion, so I will give you one ions have bivalent, which is two positive ion. So the cell will make this plateau. As you see, there is some plateau from time of potassium outflux and the calcium influx. It makes this plateau, and this is the long-lasting contracting of the heart muscle. That's why the calcium itself, it's very important to help the heart muscle to contract a little bit. So this phase, we call it phase 2 action potential. So phase 0 guided by sodium, phase 1 little bit potassium outflux, and phase 2, which is this long plateau guided by calcium influx from extracellular to intracellular. Okay, so the cell now still contract. The cell itself cannot get rid of all of this, all of those. So the cell itself cannot get rid of all of those positive charge, and cannot terminate the calcium, cannot terminate the sodium. But the cell, it has to get rid of all of this positive charge. So it will open all the potassium channel to get rid of all of this positive charge. Rapid outflux, the cell itself terminate all the potassium from intracellular to extracellular in order to help to get rid of all of this positive charge. So it will rapid negative slope as you see, so repolarized happen again, and this is phase 4 cardiac myocyte action potential. Okay, in order to the cell will be resting during resting membrane potential. So phase 0 we have sodium guided by sodium influx from extracellular to intracellular upstroke that we have here. The cell itself get rid of little bit potassium, so this negative slope as you see is phase 1 action potential. Okay, phase 2 action potential guided by the calcium channel. This straight line plateau phase, it's guided by calcium influx from extracellular to intracellular, and this is the contractility of the cardiac myocyte, the heart muscle contracting, so it make like this plateau phase. Okay, the cell itself has to repolarize again. Now it's maximum excitation and it's depolarized already, so it has to get rid of all of this positive charge. So it will get rid of all of this positive charge through the opening all of the potassium channel in order to rapid outflux of the potassium from intracellular to extracellular. So repolarization already happened, so the cell return back to resting membrane potential, which is maximum relaxation of the cell membrane in order to receive new stimulus to do depolarized again, and this is happening in each cardiac cycle. Repolarization in each cardiac cycle is happening in order to generate electricity to initiate the heart muscle and the cardiac myocyte itself to contract. Okay, so now we discuss SA node action potential, cardiac myocyte action potential, from where the cardiac electricity coming and how it's generated through the depolarization and repolarization, and now we understand how it's moving from the cell to cell through the conductive system in order to initiate the cardiac myocyte to contract. Okay, this is the cardiac electricity and how it's generated. Okay, thank you for watching. If you see this video helpful for you, don't forget to do subscribe and share in order to receive notification once we have new video. Inshallah, next video we will start purely about the ECG, the positive deflections, the negative deflections, the location of the monitoring electrode, how it detects the electricity directions, how it's make positive deflection, negative deflections. So wait for next video. Thank you for watching. Don't forget to do subscribe, share to receive notification once we have new videos. Thank you.